2-1C. 2-1C, the last of our 2-1 lesson for this week. We're going to do properties of limits. Properties of limits are very helpful when solving complicated limits. And so there's this theorem 1 that's in your book, and we're going to go through all the properties of limits, okay? All right, it says here that, let's suppose that the limit as h goes to c for f of x is equal to L, okay? So it has a value, the limit has a value of L. We're also going to do the limit as x goes to c for g of x, a different function, and that has a value of m. All right, so given these, and these are all real numbers. This is all for real numbers. And given these, we're going to do 6 properties for these, okay? So property number 1. It says that if you take the limit as x goes to c, and these are kind of duh properties, like you'll see, of f of x plus g of x. This property says that basically you can take that limit sign and distribute it to both, and so your answer would be L plus M. Kind of duh, huh? It's obvious, yeah. It's a little obvious. That also works with minus, okay, and times and divide. Do I need to write all of those out? Those are your first 4. Probably? Okay. Number 2. The limit as x goes to c for f of x minus g of x is going to be L minus m. The third one, we'll do multiplication. So if you're going to take your 2 functions and you take the limit as x goes to c of f of x times g of x, you'll get L times m. And then it also works with quotients. So the limit as x goes to c for f of x over g of x, it will equal L over m as long as m is not 0, because then it'll be undefined. There you go. Those are 4 very basic, easy properties to know. And we're going to use them in just a minute. All right, number 5. 5 says that you can take the limit as x goes to c for a constant k times f of x. Okay, so let's suppose we have a constant times our function. Well, then the limit's just going to be, you could take that constant and move it out, and it just becomes k times L. K times L. And then finally, number 6, I'm actually going to add one more because it's important. Oh, boo. The limit as x goes to c for f of x raised to a power. Let's say it's the power of r over s. As long as r over s is a real number, then this is just going to be L raised to the r over s. Okay, and then the last one, which the book didn't say, but I think it's a really important one. If you take the limit as x goes to c for a constant k, it's just going to equal whatever that constant is. And that should make sense, right? If you have a graph, for example, and let's say you have a constant, like y equals 5. If I take the limit at any x value, my answer will be 5, no matter what c is. As I go to c equals 4, it's going to be 5. C equals negative 10, it's going to be 5. So a constant is always a constant.
Oh, wait, so it's addition, subtraction, multiplication,
division, power, and constant. Like multiplication by a scalar. Scalar multiplication. Scalar.
What's the 6th? Wait.
So add, subtract, multiply, divide. Multiply by a scalar constant,
Oh.
and then a power. And then I added in just a constant, which should make sense. All right, so let's do one. I'll show you what you're gonna get. You're gonna get something like this on your quiz on Friday. So here we go. Number 1. They're gonna give you the limit. We don't know what this function is. It could be anything, okay? It could be a piecewise, it could be a polynomial, who knows? But we're given that the limit as x goes to b for f of x is equal to 7. Okay, the limit as x goes to b for f of x equals 7. And then the limit as x goes to b, it always has to be going to the same number or else these properties don't work. For g of x, we're told is equal to -3. Now, like I said, we don't know what these functions are. We don't know what f of x is or g of x is. But they're going to ask us to evaluate the limits of some things. So here we go. Letter A. Find the limit as x goes to b for f of x minus g of x. Okay, and so then you're going to put your properties to work. We know that this property says that we take each limit separately and subtract them, right? Take the limit of f of x minus the limit of g of x, and what would you get? Perfect. 7 minus -3, the answer would be 10. Too easy, right? Okay, let's do a little harder one. How about the limit as x goes to b for 4 times g of x over f of x? Okay, you try this one. You try this one by your little selves. Your little self? Did your little self get it? Leave it in fraction form. What'd you get, little self? That's what I got. -12 over 7. Okay, they're pretty easy, right? These are easy, basic properties. 4 times -3 over 7. All right, 2 more of these. The limit as x goes to b for g squared of x. Now, they write that a little weird, okay? All this means is g of x, the whole thing squared. Remember when we did trig and you had sine of x squared, but they wrote it in there instead? They wrote sine squared x. It's kind of, yes, you do. You don't? Sine squared x? Come on. What's sine squared x plus cosine squared x?
1.
1. Thank you. Okay, so here we go.
The only one I knew.
Wait, do you remember that song again?
No.
There was a song?
Yeah.
No, that's the cheer. It's totally different. All right, -3 squared equals 9. All right, so you just take the limit and then square it. It's so basic. All right, last one. No, I have one more little thing. It's kind of like a review, but also new. Yeah, it doesn't. Okay, limit as x goes to b, f of x times g of x plus 4. And it's exactly what your intuition is telling you it is. There's no weird stuff going on here. It's not like log properties where a plus means a times and stuff like that. All real numbers is not the answer, but it's good. All right, so you take them individually. The limit of f of x, they gave it, what was that, 7? And g of x was -3, and the limit of a constant is just a constant. And so you end up getting what? -17. Perfect. Good job. Okay, now let's go ahead and do a little bit of review, but new. So yeah, how does that work? I don't know. We're going to do limits algebraically, but we're going to do a couple of harder ones. Wow. Usually I can't hear anything, and I heard that one. So.
Really?
All right.
Some good ones this semester.
I've got 3. Have I?
Yeah.
I'll try to pay attention more. All right, number 2. Limits algebraically. So let's start with one that you probably feel a little bit comfortable with. You try this one. Find the limit as x goes to 2 for x squared plus x minus 6 all over x squared minus x minus 2. So on your quiz on Friday, you're going to get something that looks a lot like this, where I'm going to tell you to solve it algebraically, and you're going to need to show your work. I let you have your calculator, okay? So that means I'm going to need to see work when it says algebraically, or else I think you're just graphing them. All right, so what would you do here? Factor. So take this and write the limit as x goes to 2, and then factor the numerator and factor the denominator. So then, factor it. What times what's negative 6 adds up to positive 1, plus 3 and minus 2. What times what's negative 2 adds up to negative 1, a minus 2, and a plus 1. And so we can see right away that when we plug 2 in, of course we're getting 0 over 0, because that is a factor, x minus 2 over x minus 2. And so we remove it. We get rid of it, right? You get rid of your problem areas, you remove them. And now plug it in. 2 plus 3 over 2 plus 1. So the answer is 7? 5? 5/3. How would you like to find that one on your calculator? That would be kind of tough to do.
What was Garrett's number? Was it 12?
Who? Garrett? I don't know. Okay, now let's try this one. And this one you haven't done yet. So if you feel like this is all review and you're doing fine, you might want to watch this one. The limit as x goes to 36 for 6 minus the square root of x over 36 minus x. Okay, this one's tricky to do algebraically, but we can. We did this type of problem in ham. I don't know if some of you ham kids remember this. But what we would do is we would multiply top and bottom by the conjugate of whichever one, not just the denominator. Normally we multiply top and bottom by the conjugate of the denominator, but this one we're going to do 6 plus rad x top and bottom. And we look at that like, wow, we're just going to make a big old mess of this. And sometimes, yeah, you got to crack some eggs to make some cookies, right? What else? Okay, so here we go. Let's do it. So you get limit as x goes to 36. Go ahead and take the numerator and FOIL that out. 6 times 6 is 36. Now these are conjugates. Remember what conjugates do? The outside and inside parts will cancel out. See, the outside gives me a positive 6 rad x. The inside gives me a negative 6 rad x. And then a negative rad x times a positive rad x is negative x. And then don't multiply the things on the bottom, okay? Only multiply the conjugate because you're going to see what's going to happen next. It's going to be magical. Can you see what's going to happen next already? Do you have some algebraic foreshadowing happening? Yeah? It's a thing. All right, so if you look up top, the conjugates, like I said, the OI part will always cancel out. And what are you left with in the numerator? You're left with 36 minus x. Do you see that? It's also in the denominator.
That's so pretty.
It is. So this is the limit as x goes to 36. And in my numerator, I have 36 minus x. And this is why I didn't want to FOIL this out on the bottom, so that I can see that I have the same factors. And when you have the same factors, you can reduce. So let's go ahead and reduce that. Gone. Now, can I tell you a mistake that people will make?
Yeah, plug it into that.
Well, they'll forget to put a 1 up top. Okay? Yeah. You think like your whole fraction's gone, but it's not. This part is in the denominator, the 6 plus rad x, and there's a 1 up top. And now we're ready to plug in. Okay? Now you go ahead, use direct substitution. Don't forget to do that step. Plug 36 into here, and your answer is coming to get you. 1 over 12? 112. Yeah, square root of 36 is 6. And so 1 over 6 plus 6 is 1 over 12. Pretty good? Yeah? You like that one? Okay, I've got one more, and then I'm going to have you do some practice problems on that link that I sent you on Canvas. They're really good. There's directions too. I think for the first 6 you do algebraically, number 7 you skip, and then 8, 9, and 10 you do graphically. Okay, let's do this last one. Oh, I think we've already done this one. The limit as x goes to 0, 1 over x plus 5 minus 1/5 all over x. We've done one like this before. But these fractions, these are tough. So you have to know how to add these rational expressions together, and you have to get a common denominator, and you have fractions over fractions, and it's really hard. So, should we try it with you? Sure, let's do it. All right, so it's the limit as x goes to 0. And for the numerator, this entire thing up here, I need to get a common denominator for those terms. And my common denominator is going to be a 5 and an x plus 5. Okay? Now, the denominator of x is still there. All I'm doing is this thing I circled in yellow, trying to get this down to here. So for this one right here, I'm missing the 5. So I need to multiply top and bottom by 5. So I get 5 times 1 is 5. Over here, this one, I'm missing the x plus 5. So I multiply top and bottom by x plus 5. And now we're ready to combine our fractions up top together. We have a common denominator, so here we go. We're going to subtract them, okay? So 5 minus 5, that's gone. And what do I end up with? A negative x. Be careful there. See, it's minus, and so it's going to be a minus x. So I have negative x over 5 times x plus 5. And then this is all over x still. But what am I going to do with that? I'm going to flip it. See, it's x over 1. I'm going to flip it around and multiply by 1 over x instead. Because dividing by x is the same thing as multiplying by 1 over x. All right, and now I'm ready to reduce. Because I have an x in the numerator and an x in the denominator. And so I'm taking the limit as x goes to 0 of negative 1. Don't forget that negative up there. See, we say these don't cancel. People like to say cancel. They don't cancel. They reduce to negative 1. Cancel is x minus x. That cancels. X over x does not cancel. That's equal to 1. Picky, huh? And then 5 over x plus 5 on the bottom. And finally, you get to take the limit finally after you've gotten rid of all the bad stuff. Take 0 and plug it in, and your answer is negative 1/10. Can you do one of those on the quiz? No? You said no. Yeah, you can. Oh, I can't do it. It is 25. See? I'm telling you that Miss Cowie, I would have gotten like one wrong. I would have done all this. Story of my life. So you're like, no, I can't do that. You can do it this way though, right? Okay, you can get it right. All right.